Fire away. Really? No question? Perfect. And date? I don't know, but this is gonna kill me. Try this again. Number 7? If we run out of time, I prefer to do the ones that you really struggle with as opposed to the ones that I really struggle with. 7.
I think you should just like go over it.
I got the first one right. I got the second one.
Just listen, children. Ironically, number 7 is probably the one that is the most, that you know when you say that, when will I ever do this or use this? This is one, there's no way you can get around using this. Because I can guarantee you, every one of you is gonna get something where you have to pay interest. Unfortunately, that's a thing of our society. Nobody has enough money to pay complete cash for houses and cars, so you have to borrow money.
Can you explain what those words mean?
Here you go. First of all, the only thing you have to know is this. Interest is always the principal times the rate. It's times time, but you don't have to worry about time because it's principal, and the principal is how much money that you borrowed. Okay. Balance means how much is left after that. How much interest equals your principal times your rate. So letter A, how much interest does this person pay? It's just 1.5% times $1,500. Okay. Principal is $1,500. You just have to be careful with your rate. 1.5% is not 0.15, that's 15%. It is, move the decimal 2 places backwards, 0.015. Lido, reindeer? If you're doing the math there, I don't know why I didn't line it up there. So 0, 0, this is, I believe this, 0, 0, 0, 15, 0, 0, 5, 2, 2, 3 decimal places. Okay, you are paying, children, you are paying $22.50 a month in interest. Okay, that means you're not, that $22.50 is just the money you're giving. Whoever gave you the money, you're giving them $22.50 a month for the privilege of using their money. Okay? Well, they said the minimum amount you could pay is $30. So of the $30, you subtract your principal. $7.50 is what you're paying down, how much gets subtracted from how much you really owe them. Okay? You owe them $1,500, well, you paid them $22.50 in interest, which doesn't count towards that. Then you take the $1,500 and subtract your $7.50 from it, which is $1,492.50. That's what you still have left to pay, and that's how much you're going to pay interest on for the next month. But that doesn't matter, that's not what they asked you. Okay? So you have to, what's remaining on the balance, you have to subtract. There would be my note to self, it's not that hard. Multiply the interest times the principal to get this answer. On this one, you just subtract that answer, subtract A from the original principal. Interest is a terrible thing, although 1.5%. 1.5% interest would be the interest you'd probably pay on a credit card, because this is per month. What's that? What would be that interest rate per year? What's 12 times 1.5? It'd be what? 18% a year. But you divide it by 12 because it's just per month, so it's 1.5%. That's credit card interest there, and that's probably realistic. Because you could ask yourself, if you only pay $7.50 off a month, how long would it take you to pay somebody $1,500? That's many years, is it not?
Yeah.
Huh? Well, in 1 year, take that times 10, you'd pay $75 off of that, or probably close to 80, maybe 100. Shall hammer? Oh, a package just arrived for you. I love Christmas. Number 10, what was it? Somebody? 7.5. Somebody said do 8. Was 8 part of the 8 on our package? No? I thought somebody said 8. 9 over, stop saying all. Because not all of them are that hard. Number 8, find the volume of the barn. You are using, this is not a rectangular prism. Okay, so you have to use the global formula, which is the volume equals the area of the base, and to that you're multiplying that by the height. And then you just have to figure out what the base is. We talked about this, it's the loaf of bread theory. If you're slicing this, if this was a loaf of bread, if your shed was a loaf of bread, what way would you slice it so that it's always the same shape? It would be a Cameron Atkins. Yeah, what's the base of this shape? What is the base of this? Yeah, it is the pentagon. It is this part right here. This is the base. Which means if that's the base, I try to do this right away while I'm thinking about it. What will be the height then? Because you set it on its base, height would be how tall it is, it's perpendicular to the base. Logan says 30. So I know as soon as I find the area of my pentagon there, I'm going to multiply it by 30. So I'll redraw that because I messed it up here. I would separate it into a rectangle and a triangle. The area of the rectangle is 20 times 10. So the area of the rectangle is 200. The area of the triangle, 1/2 base times height. The base is this same 20. What is the height from here to here? 5, because the whole thing's 15 and it goes 10 to there. So 5 times 20 is 100, cut in half is 50. Put them together, your total area of the base is 250. Multiply that by 30, I believe you get 7,500, whatever it is, feet cubed. Not terribly difficult. Number 9, because I'm sure that's part of an issue as well. Is that what you actually asked? Find the area of the exterior lateral surface area of the barn, which includes the area of the roof. Wait, does it say includes the area of the roof and the floor? Excludes, yeah. You already did the area of this pentagon, right? So there's 2 of those. Are you with me? The front and the back side. So you take 250 and 250. All you have to do are the 2 side walls. So the only thing you're left to do is this and the one on the other side, which is 30 times 10. I know that's hard math for you. 300 and 300. There are the lateral surface area, not including the roof and not including the floor. 6 and 4, wow, 1,100 feet squared. Stop me there if you didn't catch that. We already did that front. You have 2 of those. You've got a right side, left side. That's these 2 right here. Number 10, a model of the barn is a scale 1 to 10. What is the volume of the model? And this probably is the best way to do this. Okay? On your model, I'm trying to think if we do it this way. There's model to actual. Model is 1, actual is 10. What is the volume of the model in cubic feet? Well, the actual was what? What was the volume of the actual one? 7,500. So what number would go here? 10 times what is 7,500? 750. So 1 times 750 is 750.
7.5. Well, yeah, but it's volume, so it's a scale factor cube.
Oh, sorry about that. There you go. You got me on that. Whoever said that? Yeah. Remember, this is scale factor. So if its volume scale factor is cubed, so you have to take 10 times 10 times 10. It's actually 1,000 times smaller. So you would divide by 1,000. I'm sorry. I wasn't thinking. I was thinking whatever there. It is 7.5. So again, people, you don't really have to, you could just write a note to yourself on problem number 10, it's probably gonna be volume again. Just cube whatever the scale factor is and divide it by whatever the volume was. So if you got volume wrong, you pretty much got all these wrong, didn't you? There's no way to get it right if you don't get it right there. Scale factor 1 to 10. How many people got that right off the bat? Did we get number 10 right?
I did my math wrong, I got 6.5.
Okay.
Because I got.
It's really, really hard to
number
work
25,000.
Whatever your answer was for number 8 with the volume, you divide it by the scale factor cubed. Because volume is scale factor cubed divided by. Ooh, we are on a tempest now. How about number 11? The value of a car declines 20% per year. What percent of the original value remains after 20 years? Or 2 years. All right. Logically, people go, well, say it declined by 40%, but you can't do that. Okay, for problem number 11, rarely does that ever work out. You can't just think, it's not intuitive, I say. The only way really to think about this is to actually put numbers in and figure out what it is. So it doesn't tell you what the value was, so you get to make it up. All right, so what would be a good value for a car to make up?
$100.
$100. Okay, so if a car declines 20%, if it started at $100, what's 20% of 100?
20.
100 times 20%, 22, you get $20. So now you're at $20, right? I mean, you subtract, now your car is only worth $80, correct? But that's the first year. This is how much it's worth after the first year. After the second year, you have to take 20% of that again, but it's not 100 anymore, it's only worth 80, so you take 0.2. 0.2 times 80 is $16. Are you with me? So now I have to remove $16. At the end of 2 years, my $100 car now is only worth $64. Okay? Now you just have to figure out what did they ask you? What percent of the original value remains after 2 years? Okay? Which means, the best way I can tell you to do this, because there's a little thinking there, do your little percent box. You've got the original percent, it's a decrease in percent, and you've got your final number. Well, my final number was 64. Started out being 100, went down, how many dollars? Go 100, yeah, 36. Okay, now you put your percents over here. The original one was 100%, and all these numbers are going to be the same, by the way, because it's 100, 36, and 64. What percent of the original remains after 2 years? Right there it is. That's the final. That's what remains. Hopefully I got that right. 64%. This is going to be tough. I don't know if you can rise to the occasion of my challenge, by the way. To get better. That's a tough problem. This one here is a tough problem. This one, I hope you still have the little sheet, because 0.5 repeater is 5/9. That should be on your sheet. Oh, you could do it. I guess you can still do it the repeating fraction way, right? That should be one. You should know any of those. 0.1 repeaters, 1/9. 0.2 repeaters, 2/9. 0.3 repeaters, 3/9 or a third. Blah blah blah. Yada yada yada. Such that hitherto. Hey, he's still looking confused at something. Go ahead. What do you want me to do again?
I don't get a answer.
What part? Why did I what? Multiply by 80? Alright, let me go through it again. This was, we picked 100. I could have picked 200 and I would still do the same process. But I picked 100 because it's an easy number. I multiplied by, it went down 20%, so I found 20% of 100, and that was 20. So at the end of 1 year, my car is now only worth $80. Well, the next year it goes down 20% again, so I have to take that second year's price times 0.2 and figure out how much it's going down, and it went 0.2 times 80 was the $16. So at the end of 2 years, my car is only worth $64. And then I just plug that all into this whole thing here and did that there. Okay, Ron, serious and so. Same thing for problem number 13, I'll just do that because that's really fast. You should know, the word of means times. 16 2/3 is one of those goofy fractions or percents that changes into what is a fraction. 1/6. No, it's not. If you don't know that, see, this is why you're 8th graders. Could you imagine trying to do this as 6th graders? How, anybody, how would I change, how, if I don't know what that is, how do I make that a fraction? No one? Exactly, because what is this? You know percent means over 100. So you have this, I'm gonna do it over to the side because I don't have, I do have some here. You take 16 2/3 and put it over 100 because that's what 16 2/3 percent. 16 2/3 out of 100. Now you might say, well, that's how do I do something like that? It's not very hard. It's 16 2/3, divided by, 100. Make this improper, which is what, 48? It's 50/3. This is 100 over 1 times 1 over 100. 50 crosses off with 100 gives you 2, you end up with 1/6. You are going to divide this by 6 to get your answer. I feel that we're learning lots today, Claire. How about you? Retention, I don't know. Learning, Caleb is bored, but I can change that. When you get 266 on things, get used to it. This one here, I can't help you with that if you don't get that. Just know that when you make box and whisker plots, you are cutting things into fourths. Okay? This is 1/4 of the scores fall between this box, 1/4 of the scores fall between this box, 1/4 of the scores fall between that, and 1/4 fall between that. So if they ask you, it said 3/4 of the scores were above what? Well, this is 1, 2, 3. This is the top 3/4 of the score. So they had to be above 82. If they asked you for the middle half of the scores, that would be from here to here. If they asked you for the lower quarter, it's here. If they said lower half, it's from here to here, upper half. As long as they're giving you quarters, it shouldn't be that hard. What is the top quarter? Right here, from 95 to 100. What's the bottom quarter? 75 to 82. What's the bottom 3/4 have to be? Below a 95, because this is 3/4, and that's the bottom part. Logan? What was number 6? Number 6, again, pi over 12. Want to do that one real fast?
Yeah.
Sure. Number 6. The rectangle shows the boundary in which the space captures, and the circle represents a 5-mile range. The recovery ship, what is the probability of the capsule landing within the rectangular region and also lands in whatever region? Oh boy. So what are you looking for? Probability is, it's the area of the circle over the area of the square, or the rectangle, I guess it is. Well, you know that the rectangle is 15 times 20, is it not? What is 15 times 20, somebody? Yes, 300. Area of the circle is pi times radius. So it's pi times 5 times 5, which is 25. And I'm going to guess if you take 25, divide it into 30, you're going to get
1 over 12.
300, I'm sorry, divided into by 25, because you can cross cancel these two. 25 goes into 30, 12. So that is a pi on top with a 12 on the bottom. And that is all. Piece of cake, if you will. Everybody say hi to, who's not here? David, hi, because you're
Hi.
watching. So
Hi.
you're probably watching this, and Alex is probably watching too at home. See how that works. Madison,
What was Tio's name?
the answers? Wow, I'm blind. 2 is 27, and 3 is 59.4. I hope. Is that the right one? Yes. Other ones? Strutzel.
How do you do 1, 2, and 3?
Gloria completed the 120-mile trip at a rate of 60 miles per hour. Returning home, there was traffic, and she averaged 40 miles per hour. Find Gloria's average speed. This has to be, Caitlin, this has to be total distance divided by total time, because that is what your speed is. You have to take the total distance you went and divide it by how long it took her to do that thing, and that's where drawing pictures helps. What did she do? She went 120 miles. At how fast? Caitlin, 120 miles?
16 miles per hour.
So that means it took her how long to do that? If you're going 120 miles at 60 miles an hour, how many hours is that going to take you?
2.
2. So there's the time for that. On the way home, which is also 120 miles, she only went 40 miles per hour, which means it took her how long? 3 hours. So now we've got all our numbers here. What was her total distance? 120 there, 120 back is 240 miles, correct? And what was her total time? 2 hours there, 3 back, 5 hours. And notice you have miles per hour as your label, because it was miles over hours. If you take 5 into 240, I'm hoping it is what, 48. Everybody's happy with that? A cube, 10 centimeters on the side can hold a liter of water. A foot is about 30 centimeters. How many liters of water can a cube 30 centimeters on edge? All right, jotting down what you know. 10 centimeters on a side. First of all, let's do that. If my cube is 10 centimeters on a side, what is that at volume? 10 times 10 times 10 is? 10 times 10 times 10 is? You know that 1,000 centimeters cubed is 1 liter of water. They told me that right there. Correct? Actually, I believe you probably could do scale factor on this one too. I don't have a 10 by 10, I have a 30 by 30. What is the volume of a 30 by 30 by 30? Ryan, 30 times 30 times 30?
2,700.
27 with how many zeros? 3.
27,000.
27,000 centimeters cubed. So, if 1,000 is 1 liter, 27,000 is? Anybody? If 1,000 centimeters cubed is 1 liter, 27,000 centimeters cubed would be how many liters? 27. And again, think about what was the scale factor? 3. Cube it, and you've got how many times bigger it is. It was 1 liter, 27 times bigger is 27 liters. And then, does this go to the same thing? A kilogram is 2.2 pounds. We already did this. 1 kilogram equals 2.2 pounds. No B's. A cube of water, 30 centimeters assigned, is how many pounds? We already did this. We know the volume is what? 27,000. What is our, how do we make the connection here? You need to know how much, what 1 centimeter cubed weighs. Remember? It's real easy in the metric system. They make it easy for you. 1 centimeter cubed, ladies and gentlemen, is 1 gram. 1,000 grams is 1 kilogram. So if you have 27,000 of these, you have the same thing. It is 27,000 grams. And 27,000 grams is how many kilograms? Taylor. 27,000 grams is how many kilograms? 27. So now I just use this as my unit multiplier. 27 kilograms over 1, you get kilograms to cross off. 1 kilogram is 2.2 pounds. So you multiply 27 times 2.2, which is what, 54? 59.4 pounds. Is that right? Yeah, the metric system is real easy, people. Then you start getting into pounds or whatever. Just know you have to convert from one to the other. We might come back to that. Better get all the work on that. Anybody? Somebody said 4. Who said 4? You draw 2 marbles from a bag containing 3 red marbles and 6 blue marbles. What's the probability both are red? Here is your deal. Probability of both being red. Just know, it doesn't matter if you draw them at the same time or one at a time. The probability is going to be the same. Okay? Just know that this is, you're not putting the first marble back in before you pull out the second marble. So here's your picture. You have 3 reds and you have 6 blues. My probability of pulling 1 red out, how many reds are there? 3. How many total marbles? 9. Okay, but if I take 1 red out, this red is now gone. What's my probability of doing it the next time? How many reds are there? There's only 2 left. And how many? 8 marbles. This is going to be your probability if you just do the math there. What is it, 6 over 72, or cross cancel, it doesn't really matter. This is 1/4, this is 1/3, you get 1/12. Probability of pulling 2 reds out is 1 out of 12. So much to do, so little time to do it. Number 5. Number 5. This is an example of what? Inverse variation. If I'm doing this one, the first thing I do is this. I'll make myself a table. And it says, this is painters and this is hours. If 4 painters can do it in 15 hours, that means if it's inverse variation, everything always has to end up being 60. That's how many total hours it took them. No matter how many painters it is, it's going to take 60 total hours. 5 painters would take how many hours to give you 60? 5 times what number would give you that same 60? And that is 12 hours. I don't know why this is not working. Who said do every one of these? Ron, was that you? Who? That was one. What do I need to do? Somebody? I'll take suggestions at this point. Who? 15 or 16?
Both.
Well, children. To figure out number 15, I guess there's 1 of 2 ways. You could either graph it, or you can take these points, put them into this equation and see if they work. Y equals 3x minus 5. If I put negative 2 in for x, oops, I'm sorry. If I put negative 2, sorry, alright, I'm going to redo this here. If I put negative 2 in for x, am I going to get 1 for y? If I do this whole problem, do I get a 1 over here? 3 times negative 2 is negative 5. Negative 5 and negative 5 is negative 10. This one does not work. If I put a negative 1 in for x, 3 times negative 1 minus 5, am I going to get a 2? Well, 3 times negative 1 is negative 3. Negative 5 and negative 3 is negative 8. This one does not work. If I put a 2 in for x, am I going to get a 1? 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. I hope we're these the answers, because if not. Or if you graph it, if you graph that equation, it is what? Crosses the y-axis at negative 5, 1, 2, 3, 4, 5, has a slope of 3, so it goes up 1, 2, 3 over 1, up 3 over 1. Which one of these points are going to fall on that? Is negative 2, 1 on that line? No. Is 1, 2 on that line? No. Is 2, 1 on that line? Yes. Falls right there. 2, 1. That's happy, isn't it? Man, so what do you think of that? We have enough time to do one more right now. We could finish this at the end of the day. But let's do one more. Which one of the 3 that are up there? 16, 17, or 18?
No, 18.
18. Oh, children. Children. Somebody, how are you going to do 18?
Cross multiply.
Cross multiply.
Okay.
2.7 times x equals 18 times 12. Is that right? 18 times 12 is what? 36 and 18. 216 equals 2.7x. When you had a calculator, you did this. How do you find the answer? Divide by 2.7. Anybody? What is 2.7 in there? 217. What is the answer to that? E.
I realize you spent 4 on this test.
I will. I kind of am ashamed and embarrassed to say that.